that. Alrighty. So here we are for the week. I built out the views of what to kind of focus on for this week's lab. Um, I'm going to go through them in kind of step by step. But the first thing I want to do is make sure, is there any kind of immediate questions that I can help answer? Because I do plan on going through kind of step by step how to approach the analysis this week. But I just want to make sure there's any immediate questions or anything I can help with just out of the gate. I want to get those addressed with y'all first.
Well, I had a question on how I got started incorrectly on this last assignment, but I really wanted to focus on what's upcoming rather than the rearview mirror. But maybe I can do that separately.
Sure.
Um, okay, because I don't know how I got off on the wrong foot.
No, fine. And I understand. Yeah, I remember that. So we can, a little bit later here, we can talk about that. I can pull it up and I can show you that piece. No problem. Uh,
Okay.
okay. Well, yeah. So this week we're working on is new data. So this time it's the house sales data, right? So obviously, there it's already, here it's already put in. I think y'all at this point are very familiar, obviously, uploading a new file, getting a new folder. So, but this week what we're working with is house sales data. So, part of mine in the marketer position, if you're selling homes, what's important, right? And for most of us, when we're buying a home, it's number of bedrooms and bathrooms, how big it is, how many floors, and for a lot of the time though too, is it by the water? And the other variable that's important to know here is it going to be in a certain condition, right? So a scale of 1 to 5, how relative it is to age and grade, right? So these are things that will matter to us as a marketer because it's how we're going to tell people who care about a really good condition home versus those who are, okay with average. Or I don't know how many people want a poor, worn out home, but hey, at least we have that um, kind of condition code, right? So that's what 1 through 5 means in the data. And the grade meaning all kinds of things, right? Like they've actually got out and detailed out what each of these 1 through 13 means. Based on standards of the building, construction, is a meeting code. Probably most of our customers, for a home builder or home realtor, is going to want to sell homes that are in the 9 to 13 range. They're meeting code. They're built well. But then may have people who want remodeling homes. So there's a segment there for that, right? So I'm kind of just showing you the different ways you can use the data points just to think about what the data means and why it's important in marketing, especially. So perhaps we want people who are flipping homes, they want a house that's maybe the middle of the road condition and grade, so they can actually have a project, something to work on, right? Set the market to them if it's a really nice built, ready to go kind of mansion, that kind of thing. So that's one way to think about the purpose of the data and why these variables exist. So I'll stop there just to ask, is there any questions about what the data means and kind of why it's important to think about those aspects, if you will, of the data itself?
No question.
Cool. Okay. Yeah, because I always like to start from the bottom up, right? Like, what are we trying to solve? Why is the data here anyways? What is the point of all the data fields? So that's really, really bad. So the next thing I recommend always doing is just run your summary statistics. So for this, you're not so much doing this for this assignment, right? This is just good practice. You've done this summary statistics before, where you've built in the data, right, to look at it from a summary view. The good point about doing this is just getting more familiar with the data, right? So before we can do the correlation analysis, the linear regression analysis, the new ones we're doing this week, it's really important to just run the actual summary statistics. And so for this, I'm going to show you for practice today. We're really focused on price, right? Is price influenced or not, right? We're looking at, is price a predictor based off different variables down here? Like I've got number of bathrooms. The assignment you're going to do is number of bedrooms. Okay, so it's when you get to the correlation analysis, that's really what you're going to do, and then square foot of living as well. I'm going to show you with bathrooms just as an example because I really want y'all to practice with the variables you're actually going to work on, right? Which here again, when you get to the problems, you're doing number of bedrooms and price. And what you're trying to figure out in the hypothesis and really understanding is, does it matter on the number of bedrooms or not? And the hypothesis could be that yes, right? The null hypothesis could be that number of bedrooms is a significant impact to the price of the house. And then the alternate hypothesis is no, it's not, right? So that's kind of what we're doing here as far as what we're analyzing, and innately we may think yes, because sure, 4-bedroom versus 5-bedroom really makes a big difference on the house price, but does it, right? Like that's the thing. Sometimes there's a big difference between a 2-bedroom house and a 5-bedroom house, but 4 and 5 maybe not, right? A 5th bedroom, how much really different is that in the vein of understanding the analytics, right? Does that make sense? So the first thing I'm going to say is that I want to run the summary statistics on price, and I'm using bathrooms, right? So the analogy here is you'll do it with the actual bedrooms when you actually do your assignment. But I'm going to run my summary statistics first. I'm going to build this in, already built it. So you just drop in your price here, right? And you drop in your classification variable. Here I just brought in, it was here, I brought in bathrooms, okay? Now, what I like to run too in the summary statistics, again, this is just for, again, getting familiar with the data before you even run a correlation analysis. It's just to build your kind of knowledge about what you already have in front of you, right? So all of the standard stuff in the statistics are checked. So your mean, your average, the minimum, maximum values, standard deviation, all of this stuff is already built for you. And then I always think it's good to build in your histogram box plot, okay? In previous weeks, we're doing it again to kind of build upon the skills of where we're at. And once I got these checked, I'm just going to run the analysis, right? I'm going to run. It'll take a minute. And so I've got all these results now. So what I'm looking at now is based on the number of bathrooms in a home, what is the average price for that, right? And that's just something to keep in mind. So, bathrooms, I guess, in the world we live in is, a full bathroom versus half a bathroom. I guess you could say there are some homes that classify 1.75 bathrooms. I really guess that's like, maybe that's kind of saying it's got a C. Will it? I really, to be honest with you, I don't know why these are in 0.25 increments, but imagine that's the world we live in of selling homes with bathrooms. But really what we're saying is a one bathroom in a home, the average price is $347,000, right? All the way down here, if you have 8 bathrooms, it's really expensive. What is that? $4 million, $5 million almost. So we're really just looking at the correlation between the number of bathrooms and the average house price. And then here we can go through the histograms and the viewpoints of scatter plots to really look at it from that perspective, just from a visual perspective. I think the bar graphs are better. Again, this is just going to get familiar with the data. You're not really doing any insight here. You're just learning about the difference between the different pricings and number of bathrooms at that level. Here, a scatter plot really shows it to you pretty well. And it kind of does show you that the higher the number of bathrooms, the higher the price in a way. Down here, though, it starts to drop a little bit. There's not a lot of difference between 3.5 and 4 bathrooms in price. Kind of stay relative. So that's what I was saying earlier. Innately, we think, yes, the number of bathrooms, but maybe for the homework you're doing, the number of bedrooms, sure. 1 and 2 definitely have a difference between 3 and 4 bedrooms, but if I have 2 bedrooms versus 4-bedroom homes, yes, usually they cost more if it's a 4-bedroom home, but there's really not a difference between 3 and 4 is what I'm trying to say, right? There's not really a big delta or difference here. They're relatively similar, slightly higher in 4, but not a lot different, right? So I could have a customer group, a segment that I could say, look, here's a house with 3 bathrooms or 4 bathrooms, and it depends on the customer and if they're willing to look at a house. They're really steadfast to have 4, only show them 4, but you may be able to target a group of customers and say, here's a house with 3 to 4 bathrooms, right? Maybe for the bedroom example, you could group that together to say 3 to 4 bedrooms, because it depends on the home buyer. Some may settle for less or more. It just depends. But this is the starting place just to get familiar with the data. Any questions about this?
No.
Makes sense so far?
Mm-hmm.
Okay.
No question.
Yep. So that's kind of where you get your thoughts going on the data and summary statistics. But now we'll really start running the actual analysis for the week. So again, you'll be doing the number of bedrooms. But here I'm going to pull in the so correlation analysis, right? I brought this over. Double click here. And what you're going to do is you're going to bring in these other variables. But here it says correlation analysis. What I've done again is I've just done the analysis variable is price. We really want to know the price impact based off number of, excuse me, remove that. Once you bring in price, make sure you bring in price under analysis variable, and then correlate that with, I'm doing bathrooms. What you would do is you would actually do bedrooms. It's the only difference, right? So when you get to here, this is built. This part's built. This first step under data is done. Now there's some steps though under options and output that I'll show you in just a moment. But data, again, your analysis variable is going to be price. This is going to be question number 2, right? You're going to look at the correlation between price of a sold home, and you'll do the number of bedrooms. I'm just showing you as the example the number of bathrooms. Bring that in. But the next step you want to do after you get to this point, where this would actually be bedrooms in your assignment, go to options. Now, under options, these are all the things you want to have checked, okay? So that's why I'm glad I'm recording it, because you can always come back and refer to it. What's going to happen out of the gate is that your correlations checkbox will be there. Under statistics, you want to drop this down and bring in a few additional fields, if you will, for your output. Correlations already is going to be built because that's where you're doing a correlation analysis. You're trying to figure out, is there a correlation on the impact of price and the number of, for your assignment, bedrooms. I'm showing bathrooms. But it is worth also saying display your p-values. This will also need to be checked to show the point of 0.05 above or below. As y'all know, the confidence level of 95% or the p-value 0.05. Well, if it's below that, that's showing we're closer to significance. Or if it's above it, it's not, right? We want to be as close to 0.05 as possible to show that significant value. I'm going to stop there. Do y'all remember that piece of it for what you've been doing so far, as far as saying is something significant and it truly does prove a hypothesis or not? Is that ringing a bell?
Yeah.
Yes.
Very good. Cool. And that's the part that really, for this, you're going to look at for again, right? You're going to look for that p-value. But you're also, for correlation analysis, going to look for another number, which I'll show in just a minute, to truly say, is it correlated based off a correlation analysis? What's interesting about, anything in analytics is you could have an element to have one or two different scores or metrics that really tell you it's like it's significant or not, right? But p-value is one of them. Check your covariances and descriptive statistics. These right here are just good to have, again, as a gut check on the data. You already did that descriptive statistics with the summary here, but you can just bring it in again. It just helps to make sure that you have a validation check that the mean and the averages, all that is legit for the most part. So really, after that, you just have to, that's all your methods. Okay, so it's everything in methods you want to have checked. Then under plots, just pick matrix of scatter plots and include histograms. Okay, for that, and then under methods, nothing will need, you won't have to do anything under methods. It's already done for you. There's nothing here you have to do. So again, the only thing you're going to check again is statistics, correlations should be rechecked. Just make sure display p-values are checked. This order correlations highest to low, covariances, and descriptive statistics. The variances again are going to give you like the the difference between the two different measurements, which is going to be your average and between the price and number of bathrooms. So after that, you hit run. I've already done it, but you hit run, and this is your output. And this is the only output you have to screenshot for that question. Okay. So again, yours will say bedrooms, but this is how you're going to read it. The two key areas to really look at here is, well, one, make sure that all the number of respondents got in here, which it should. 215,000. But what you really want to look at is this right here. This number is going to be your correlation coefficient number here. So it's asked the question in the bedroom, for the bedrooms, what is the correlation coefficient of your output? Okay. Well, it's this number again, right here. This 0.52517 is the correlation coefficient final output number of analyzing between price and, for this, bathrooms, yours would be bedrooms. Then it's like, all right, from that point, we've got it, right? What is it? That's the number. What's good or bad? If it's positive, it's good. If it's negative, it's not so good. Pretty straightforward. So here's what I mean. A 0.52 shows that there's some significance between the price and number of bathrooms in general, okay? And when I say in general, that means that for all the homes within this survey, or this, all the data in this data set with all 221,000 homes in this assessment. So that's really all you're saying, is that yes, it is significant because of that number alone. You want it to be positive to show a correlation. And that's really what you're doing. That's the final output and the final assessment from this question. So you just literally answer it. Is it positive or negative? And it's also, by the way, how do you answer if it's weak, medium, or strong? The closer you are to 1, a positive 1, the stronger you are, okay? So for 1, this is positive. That's the one answer you would give for bathrooms. Again, you would do this for bedrooms, but you'd read it as 0.52 is positive. So yes, it means that it is a correlation. There is a positive correlation. It's a medium, though, in how strong it is, because the closer to 1 you are, the stronger you are. On average, they say if you're 0.75 to 1, you're strong. If you're 0.1 to 0.4 or 0.35, you are low. This is right in the middle. Does that make sense? It's kind of a barometer effect, like how much of an impact is that 0.52 number, right? It's almost kind of saying a 52% significance of correlation versus if it was 0.85 as an example, it's a stronger correlation, even more so. So this is still saying that it's a positive correlation, but not as strong as if it was a higher number, right? Does that make sense?
Yes.
Okay. So what you're looking to do here is just answer your question for bedrooms. Let's say that this was bathrooms we were doing. You would just say, again, this is a moderate correlation because it's 0.52. And because it's, again, in that medium range, that's really what it is. You would put positive. And what is your final conclusion? A final conclusion for this, and I'm going to tell you this right now, the bedroom number isn't going to be that exact 0.52 like bathrooms, but it's relatively going to be a similar answer. So I'll tell you that right now. You're gonna see that the number that you get here, it's kind of close. So you can take that with what you will, and then your answer for bedrooms will be relatively close too. But what I'm saying is your final conclusion. This is where you just put your own spin on it. So what I would do for bathrooms is say, because the bathroom number of bathroom correlation, coefficient is 0.52. This means that the average home has some or slight impact on the number of bathrooms to the price, right? But it's not to say that every house and buyer out there of a home, it matters to all of them. It matters to some, right? It's that directional insight. The final conclusion is some buyers do care about the price they're willing to pay for a home based on number of bathrooms, but this is not conclusive to say all homes or all home buyers, right? It's some of them. That kind of conclusion is really all you have to say. Does this make sense?
Mm-hmm.
Yes.
Okay. What else can I answer about correlation? Because that's really the walkthrough on that piece. Any questions?
I'm just curious whether you got a scatter plot in your results here, because didn't we select for you to get some type of a graph that didn't show up?
Yeah. So the issue with this is because the variable is so minimal, there isn't one. So you don't have to worry about that here. You will get it though under summary statistics, only because it's reading it with all these other observations here as well. Sometimes a correlation analysis, it's not going to pull one out because it's not reading the median, the mode, all these other, how do you say, measurements, if you will. So that's why we're not asking for one in this question. Does that make sense?
Yeah. Mm-hmm.
You want to pull it
what?
from your summary statistics here.
So that number 5, is that just a standard number that's always there, or when did you put that number in?
Number
Or how did it get there? Under plots.
plots. This one here is already is default. You can
That's
do
the default. Okay.
Yeah. Right, and we only have 2 variables though. So let's imagine we pulled in another 5 variables or more than 5. We had the square footage. We had the year it was built. All that. That's why we would need to expand this further.
Mhm.
So for this question though, here you'd want to pull it from this view under summary statistics to pull in the box plot. But what we're really looking for though is this final number here and what it means to the analysis.
Okay.
Okay.
Thank you.
Yep.
Thank you.
So the next step is, how do we look at doing simple linear regression? Okay. So for this one, what we're going to do is I'm going to go down the path of price. For this, you're going to do square footage as the analysis between now square footage and price, an impact in that type of analysis. So what I have built here is what we're going to do. I'm going to go back to the very beginning. So data. I'm doing bathrooms again as well. I'm going to keep the bathroom theme for this example. But what you would do is the exact same thing underneath this from a square footage perspective. So really here, you'll pull in linear regression, double click that. This would pop up blank, right? But then you would just bring in price under a dependent variable. So again, you'd have linear regression, it'll pop up, your dependent variable against price. Everything we're looking at is how is price impacted by these different parts of the home. Here though, you would do square footage, living versus what I'm doing is bathrooms again, but for the sake of the example, I'm doing bathrooms. Bring that in, and the rest of it down here should be, there's nothing else you have to do under data. Again, just these 2 variables here. Now, these are all the things you want to do under model. Now, model, what you're trying to do here under model is a linear regression, like the shows, is you're really just trying to compare on a Y and X axes, right? You're trying to see where does the majority of, in this data set of all these different homes surveyed or assessed, 21,522, where's like that, it's called the slope, right? Where do these 2 variables kind of combine on a slope, right? So I'm looking at 21,000 homes. Where is that kind of intersection between bathrooms and price in general? Okay. So here you have to go to edit. And since I picked bathrooms earlier, whatever you pick in data here under classification variable, once you add it, it will also show up over here as a variable. But you have, actually what I'll do for this is, well, I don't want to do that because I'll take away the results. You have to double click this and then add it, okay, to get it over here under model effects. The reason why is, imagine if you had more than one classification variable here. You had condition, you had floors, number of floors. But what you would actually need to do to look at it is see which ones do you want to actually analyze in this analysis, right? It's just another step, to be honest. I'm not sure why SAS did it that way, but it's just another step to make sure that this is the one you want to look at. This is the one that you have to add into the model effects builder. All you're doing is building which one you really want to analyze in the visualization. So that's just one thing. So again, though, what we're doing is we're going to remove these out of here. Take those out. You would have bedrooms in here, though, versus me trying to remove these. They're not going away. Well, I only have bathrooms selected anyways. Bathrooms, intercept, add them here. Okay, and that's all you're doing under model. Options is where you're going to spend a little time looking at a couple different things. Confidence level, 95%. That's usually the default. I would stick with that. What I would make sure is that you're under here, go to default and selected statistics. When you open it, it's just going to have default statistics. What you want to do is open up default and selected statistics, and then select standard regression coefficients. It should already be checked, but just in case, make sure it's checked. This one's going to give you the final output of the number to assess in the regression analysis. This what helps give you something called the R-square score. This is the score that's going to assess the significance level in a linear regression. The rest of it you can leave alone. Down here under plots, you can check diagnostic plots, residuals from explanatory variable. This again is just visualization. And then also observed values by predicted values. I'll show that here in a minute. Just make sure these 3 boxes are checked. And then selection, you shouldn't have anything here to do. That's it. So really, again, I'll walk through one more time. The data, bring over bathrooms into the model. Carry it over here. Options, make sure to check the default and selected statistics. Check box the standard regression to coefficients. And these 2 boxes here for the plots. And that should be it. Once you run it, hit run, you'll get this output here. Okay. Now the output here, the one that you want to look for immediately, what is the p-value? This is it right here, okay? So it is going to be a 0.0001. So it's pretty low, right? So already out of the gate, this is showing not a significant value, right? The p-value here is the first thing you want to look at. The next thing I want to draw your attention to is this R-squared score. All right, so R-square is a 0.356. Again, is it good or bad? This is different, though, than the last one I showed you. Remember, correlation analysis, that final correlation number, the way to think about this one, again, is it positive or negative first? Automatically, it's positive. There's something that says yes. But remember that a 0.5 in the scale of 0 to 1, right in the middle, it's moderate. It's a moderate impact. The difference with an R-square score is that no matter what, you're more than likely to have something between 0 and 1 normally. What this means is that for this, it's a 0.35 is low, that this is not significant, that it's a 0.35 would say kind of the same thing as before, but you're not going to have really a negative number in the R-squared. It's going to be somewhere between 0 and 1. But this is showing right here, this R-squared, this exact number is what you want to show as the regression result. That number right there is the one that's going to tell you whether or not this is significant, and anything between a 0 and a 0.3, 0.35 is low. It's weak. There's not a correlation here, right? And it kind of supports what we said earlier a little bit. But the difference is because this is moderate, this is low, it's still relatively saying that there's not something significant here. Like if this was a 0.8 and this was a 0.7, you know what I mean? Both analysis types would tell us that there is something significant going on here. Really, it's moderate to low is what we're saying, which kind of makes sense, right? These are 2 different analysis types, but they're both telling us relatively that bathrooms and price are moderate to low in both sets of analysis. There really isn't a strong significance on the price of a home based on the number of bathrooms. Does that make sense?
Let me make sure I understand that. So, okay, if the p-value is low, then the null hypothesis is rejected, right?
Right. If your hypothesis is that there is a correlation and significance between number of bathrooms and the price of the home. So you're right. We are going to reject that and say there is not a significance to that. So you're correct. We would reject the null hypothesis.
Okay.
Correct. So we're definitely going to reject this hypothesis in general because there's not a correlation, a linear regression significant showing us that there's impact on price because of the number of bathrooms. But you would do it for the number of bedrooms. I'm going to give you a heads up again. Relatively similar. So that's really what you're trying to achieve for that question number 3. So what is your null and alternate hypothesis again? Our null hypothesis is that there is an impact between, for this, square footage and price, although I'm doing bathrooms. But the alternate hypothesis is that there's not a strong correlation between price and square footage. Then you run it, show the output like I just did, okay? And then what you would do is go through and talk about the assessment of the result from there. What is the R score? What is the interpretation? Well, it's pretty straightforward, one sentence. The R square score for this one is 0.3567. That is a low R square score. So my final conclusion is because of that, there is no significant impact. We would reject the null hypothesis. Make sense?
Yes.
Very cool. Okay. So the other thing to this, by the way, let me scroll down a little bit. Well, no, those are just, I'm just looking real fast to make sure I'm not forgetting anything. Yeah. So that is that from that perspective. Now, from the next phase of it, though, the multiple regression piece, the only difference with this is you're going to do, remember earlier on you did a exercise to change the variable from a year someone was born to the age, right? Because you couldn't, because I think I shared it as well, where, you know, someone was born in, let's say, 1980. Well, if you're studying this in 2022, their age changes if you're studying this in 2023, right? So remember, there's a way to change your age, if you will, because of the year that someone was born. Here you have the year built, so you're going to have to go back and do that same kind of change of a variable and call it age and do the subtraction again from 2022 minus the year built. Do y'all remember that?
Yeah.
Refresh my memory. I remember it, but refresh my memory since we're here.
Yes. No, I understand. So for that, I'll have to pull up the one second.
That's the one where we put it in parentheses and yeah, I want to see that again.
Yep. Let me try to see if I get the other salary data. So what I don't want to do is close this out to show you the other pieces. Let's see here. I should have.
Can you just send it to us after this is over so it won't mess up your
Yeah,
phone?
I got a shot of it, and I got the, and there's a there should be a video as well. I'm happy to share it. Yeah, I'll do that for you. Yep.
Okay.
Because really, all you're doing again is let me go back to here. Okay, we're here. Is all you're really doing again is that step, right? Creating the variable age, and you're subtracting the year a home was built from 2022. Once you have that, then you can run the rest of this the same way off that. But the difference is between a multiple linear regression, what you guys did, is just that you're bringing in multiple variables now. Okay, you're just going to bring in each one to see if there's any other impact for price on any of these other variables. So when it asks for age and year built, you're just going to run that and see is there a difference in that now, right? Compared to when it came to condition. So what we're saying is you're going to run each of these by itself. You'll run a linear regression on year built and age. You'll run one between price and condition. And what you're going to do is you're going to compare and contrast the two. You're going to have two outputs now of each of those comparisons. And you're going to now come up with some kind of insight, right? That based off looking at the different views of age versus the year, age versus price of a home versus price and condition of a home, these matter or these don't matter, right? Like you can combine them and say too, if it does make sense that how old a house is and the condition of the house is both matter in the significance of it in the R squared result, then yeah, that we need to combine those two things as far as how we market to our customers, right? And probably, I would think the older the home, the more of a poor condition it's probably in, right? In theory. So that's why you want to run that and say this is price impacted by both age and condition of a home. So you'd run each of those and then do a comparison of each one visually and come up with your assessment. Does that make sense?
Yeah.
No.
Sorry?
No, Mika said no. I said yes. I said no. I need clarification on something.
No problem. Go ahead. You'll
So,
go.
so you mentioned that with this multiple regression, we're doing multiple variables. Then in your question, you asked for us to run each variable separately and analyze it. Why aren't we just putting all the variables in and getting the analysis from that?
No, that's
Why do we? Hmm?
you're gonna do that. You're gonna take so for this. Let's say I'm gonna take out. You'll run this together, right? And when you
Okay.
run, you're gonna get that right here exactly. So you're correct. When I'm yeah. So I maybe I misspoke. You're gonna run. So for this, I have price. You're gonna do age of the home, and then the other one you're gonna do condition, right? So for this, bathrooms and condition, absolutely the same thing. You're going to compare between the two, and then look at your adjusted R scores and see if there's a correlation or not between those two. Correct.
Okay.
Yeah, absolutely. And that's the only difference is that is another variable, another layer, if you will, in saying another characteristic of the home that make it different. And that's all you're for that.
Mhm.
Now
And
the
then we're creating a column for year of home.
yes,
Age of home.
age, like how old the home is, correct.
Okay.
And I'll send that to you too again about how to pull that up together. Now for
Okay.
question 19, here's the kind of difference between what I just showed you and what this looks like. Under options, actually excuse me, selections. Under selections,
Kyle.
hi, hi, can you hear
Hello.
me? Hello.
Yes.
Sorry. Yeah, my mic on my laptop doesn't work, so I had to redial into my phone. Sorry about that. Okay.
Okay.
Still see my screen?
Yes.
All right, great. So for this under selection, under question number 19, it asks you to run it within Akaki's information criteria and Schwartz Bayesian information criteria. These are just some fancy names of some gentlemen that were able to come up with a great algorithm. But what I love about modern technology is we're not going to have to do those by longhand statistical analysis. So all we're asking to do is get the view of those statistics in this view, if you will, of the data. So that's the easy part. So years ago, without these what do you these tools, you would have to do it by hand. So, anyways, under selection, you're going to go under where it says model fit statistics, or excuse me, model selection. You're going to pick forward or backward. Okay. It's going to ask you to pick either one. It doesn't matter which one you pick. I'm going to tell you that right now. Because all it's going to be is how the data is displayed at the end of the day and which column comes first versus second. I recommend forward selection. What forward selection means is that the data is going to be pulled together to run another kind of validation check on the significance of the output. It's just another validation check to make sure that we are running every statistical method out there possible for linear regression to make sure that we have, even more of a confidence in what we're seeing. That's all this is. Okay. And already when you pick under model selection, forward selection, right here you see that Bayesian information criterion. It's right there. Okay. You'll run that and then see the output of information down here. And this is the view. Now, how do you read this view? It's pretty straightforward. You have to look at it. Here's the AIC. That's the Akaiki information criteria. And then the other one is going to be down here. Well, where'd it go? The BIC should be somewhere. Oh, SBC. It's the same thing. Schwartz Bayesian information criteria is the same thing, by the way, as the
Yes.
Schwartz Bayesian criteria. Yeah. Sometimes I forget that the Schwartz is included. BIC and AIC is also how you also refer to it, but yeah, it's going to be these two. So what we're saying is that these two are the same, meaning that because of this, these two being the same look and feel on the slope, if you will, the stars or the dots and stars are they're accurate enough. Meaning that yes, again, we have another validation checkpoint that this is the results show us that there is a non-correlation between the data. Again, this is telling us yes, again, this is another impact to the price that bathrooms are not there. If that makes sense.
Is that because they're the direction that it's going in is downward sloped?
Yes, ma'am.
Okay.
Downward slope. Yep. Because the significance is right here on the intercept of the method of measurement here, right? So the further we go down, the less impactful it is. Make sense? And that's really it. I know. I mean, that's cool. I know it's. I sound like that's just how you're doing, but no, that's really what you're looking for in the result set. Is just making sure you pick the drop downs that you need to pick, and your value points are these scores, right? Is for that first question, it's this number, and then it's linear regression. It's going to be your R squared number. And then when you run the multiple, you'll just compare the two, and then find the final output of the AIC and SBC.
Okay. Good. Great. Thank you.
I hope it was helpful. Yeah. Any other questions I can help answer?
No, just when you get a chance, clarify a little for me where I got off track, or just send a little note maybe when you send the other things. I just didn't know where I started wrong.
Sure. I can. I'll send you a note. I'll show you a screen at that.
Okay, cool beans. Thank you so much.
Thank
All right,
you.
have a great weekend. Thank you.
Okay.
You too. Bye now.
Bye.